This is video B, and we're going to talk about another method for solving quadratics, and this is called completing the square. So in this unit, you do have to become proficient with all three methods. So this is kind of like what we did with systems of equations, where you didn't get to just choose your favorite. You really do need to know how to do all three methods. So this is the second one. It's called completing the square, and essentially what we're trying to do is we're trying to create a quadratic on one side of our equation that would be factored into a perfect square. And so it's not going to start off that way, but we're going to make it that way. And there are certain times when this is going to be a lot easier than other times, and as I get into the examples, I'll talk about that and how that affects the mild, medium, and spicy on the worksheets. So, if we keep this fact in mind that certain quadratics or trinomials can be factored into perfect squares, we're going to use this to complete the square. So using this, we can complete the square to solve quadratics, like this knowledge that some factor into perfect squares. And like I said, this is one of the methods. So I have listed out 7 steps for completing the square, and I could read through them, but I don't really feel like they make a whole lot of sense unless we're talking about them as we're doing it. So the first thing you need to do is you need to put it in standard form and set it equal to 0. In other words, you need to make sure that you have those exponents descending order and set it equal to 0. So that's what we're going to do here. Then, if you have a leading coefficient that is greater than 1, you need to divide all of the terms by that. So we can only do this method when a is 1. So that is one of the factors that's going to determine whether or not completing the square is all that easy, because some of a best method to use, I guess I should say, because sometimes that a value won't divide evenly into the b and c value, and you end up with fractions, and this method gets a lot harder when you're dealing with a lot of fractions. So in this case, I don't have to worry about step 2 because a is 1. Now I'm going to move c to the other side of the equation. So in this case, I would be adding 12 to both sides so that I have x squared plus 4x equals 12. Now I've left a space here because what I need to create on this side is, going back up here, a perfect square trinomial or a perfect square quadratic. And so remember, with equations, we can do anything we want to an equation as long as we do it on both sides. So I want to create an equation over here, or a quadratic over here that will factor. So I need to figure out what is it that I need to add here to put it in that format. And to do that, I take my b value, so 4, I'm going to write this right here, I divide it by 2, and then I square it. So 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add 4 to both sides, because I can do anything I want to an equation as long as I do it on both sides. This is now a perfect square trinomial, and so I can factor that. I'm going to write it in its factored form. This would be x plus 2 times x plus 2. And an even better way, I'm just going to erase what I wrote. Because those factors repeat, I'm going to write it as x plus 2 squared. And it's going to be equal to 16, because 12 plus 4 is 16. And now I'm going to solve this for x. And so this is solving for x, but there's some new parts of this. So remember, when we're trying to get x by itself, we're working backwards through the order of operations. So I have to deal with this exponent before I can deal with anything inside the parentheses. So when I'm solving these, the first thing I'm actually going to do is take the square root of both sides. When I square roots, an exponent of 2 cancel each other out. So on this side, I'm left with x plus 2. The square root of 16 is 4. However, I have to consider that you can get a positive 16 whether you square positive 4 or negative 4. So there comes that plus or minus sign again. Because remember, a lot of times with quadratics, we end up with 2 solutions. Not always, but a lot of them do. And so we want to consider situations that are going to produce two solutions for us. So I'm still trying to get x by itself. My next step is to subtract 2 from both sides. And so x is going to be equal to, and I'm going to write this a way that you probably haven't seen before. I'm going to put this number first, plus or minus 4. And the way that I get to my two different solutions is that I'm now going to split this into two problems. X is going to be equal to negative 2 plus 4. And x is also going to be equal to negative 2 minus 4. That's what that plus or minus means. Get one solution when I add, one solution when I subtract. So this value will give me a positive 2, and this expression, expression will give me negative 6. So there's my two solutions. So again, we're writing things as a solution set. So x is equal to, whoops, that's a really bad curly bracket, but that's okay, negative 6, positive 2, in order from least to greatest, and that's my final answer. So that is the whole process of completing the square, and we have more examples to go through because it does feel very confusing, especially the first few times that you see it, so do not shortcut your notes this time. Things to notice: when you have an a value of 1 and your b value is even, completing the square is very easy to do. If you do the mild worksheet, it's going to work out like this for you on those problems. So the mild worksheet are kind of like your best case scenarios for completing the squares. As you move into the mild and the medium, you're going to start to run into some of the trickier situations that we're going to see especially in example 4. So it's not that any of the questions on the choice board or any of the assignments on the choice board are beyond the scope of Algebra 1. It's just how easily you're able to work through this process. So if you find this very confusing, don't start with the spicy. You're going to be extremely confused the entire time you're trying to do it. If this seems super easy and intuitive to you, then you might want to start with the mild or the the medium or the spicy. But this is kind of your best case scenario, and if this is feeling really difficult, start with the mild. Learn the process with nice, easy numbers. So now let's look at our next one. In this one, it's in standard form. I'm going to start to save space here, so I'm just going to cancel this out and put a 0. And it's in standard form, but I am noticing that my a value is greater than 1. So I have to divide all the terms by a. Technically, I am dividing the 0 by a also, but 0 divided by anything is still just 0. This becomes x squared. This becomes minus 18x minus 40. All right, step 3, move c to the other side of the equation. I'm adding 40 to both sides. That cancels out, so now it's 40 is equal to x squared minus 18x. And I need to complete this square. So I take that b value, I divide it by 2, and then I square it. So this is going to be negative 9 squared, which is 81. I'm adding 81 to both sides. So 40 plus 81 is 121. This side is going to factor into a perfect square. So my factors of 81 that add to negative 18 are negative 9 and negative 9. So x minus 9 squared is my factored form. And now I solve for x. So now I take the square root of both sides. This gives me positive or negative 11. And now I'm just left with what's inside the parentheses. I'm going to add 9 to both sides. And, sorry, I'm not very good at writing small on the screen here. So this is going to come out to be that x is equal to 9 plus or minus 11. So let's go write this out separately now. I have, oops, x is equal to 9 plus, goodness gracious, keep messing up. 9 plus 11 is going to be one solution, and x is equal to 9 minus 11 is going to be my other solution. So 9 plus 11 is 20, 9 minus 11 is negative 2. So my solution set is negative 2, 20. Okay, so now we're looking at our third example. We have x squared minus 6x equals 40. So step 1 says put it in standard form and set it equal to 0. Except, in this occasion, we're going to kind of talk about why I might not want to do that, because remember, in step 3, we have to move c over to the other side. So it's almost like that step was done for us in number 3, and I'm actually just going to leave the 40 on the other side. But I am going to rewrite it so that it's x squared minus 6x, and I'm going to leave a space to fill in whatever value I need to complete the square on this side, and I'm going to set it equal to 40. So while that is kind of some of the steps that we see, if it's only the constant that's on the other side, I wouldn't move it to put it in the standard form because you're going to have to move it again later. So in this case, a is not greater than 1, so we're good there. And so we just need to move on to step 4. Excuse me. So step 4 is complete the square. So we're going to take that b value, we're going to divide it by 2, and then we're going to square it. So negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. So I'm going to be adding 9 to both sides. So this is now a perfect square trinomial. I can factor it into x minus 3 times x minus 3, which is x minus 3 squared. And 40 plus 9 is 49. And so now we're going to solve this. We're going to take the square root of both sides. The square root of the binomial is just x minus 3. And the square root of 49 is 7, but we have to consider when it's positive 7 or when it's negative 7. Since this was just a numerical value, we have to consider that positive 7 and negative 7 both square to give me positive 49. To finish solving for x, we would add 3 to both sides. Those cancel out. And so x is equal to 3 plus or minus 7. So those are going to give us our two solutions. So 3 plus 7, x equals, and x equals 3 minus 7. So 3 plus 7 would give us a solution of positive 10. 3 minus 7 would give us a solution of negative 4. Those are our two solutions. So our solution set is negative 4, positive 10. So all of these worked out very nicely. Our b values were even so that we didn't deal with any fractions. Even when there was an a value, like in example 2, all of both b and c divided evenly by that. I didn't end up with any fractions there. So these are kind of what you can expect in the mild. In the medium, you will start to see a little bit more where you have a values greater than 1. What you see in example 4 when we get started is this is one that you're going to start to see more problems like this. You're going to see a few in the medium, and you're going to see a lot of things like this, or even messier in the spicy. So again, just to reiterate, it's not that the spicy is beyond the scope of Algebra 1, it's that the numbers aren't as nice to work with. So let's kind of look at what happens here in number 4. So in number 4, I don't have this in the standard form in the sense that I need the x squared and the 12x on the same side of the equal sign. I can leave the negative 23 as it is like I did in example 3, but I need my two x terms on the same side. I could move everything and then move and set it equal to 0 and then move the 23 back, but to me that just seems like unnecessary work. So to move the 12x to the other side, I would subtract it so that I have x squared minus 12x, and I'm just going to leave that as equal to negative 23, but let me back up here because I want to leave space for completing the square, and I forgot to do that. All right, now I am going to complete the square. I'm going to take my b value of negative 12, I'm going to divide it by 2, and then I'm going to square it. So negative 6 squared is positive 36. So I'm adding 36 to both sides. This is a perfect square that factors into x minus 6 times x minus 6, which is x minus 6 squared. And negative 23 plus 36 is 13. So this is where this problem is going to start to get a little bit harder, because notice this is not a perfect square. So in my next step, when I'm solving for x and I take the square root of both sides, I am not going to be able to take the square root of 13. And it's not a radical that's going to simplify, so I'm just going to leave it as square root of 13. This is going to become x minus 6. I still have to consider the positive and the negative, but I just leave it as a radical like that. And then I need to finish solving for x, so I'm going to add 6 to both sides. And so this is where a lot of students start to get confused, like, how do I write this? It's actually easier than you think. It's just 6 plus or minus the square root of 13. There is no, other than using decimals, there's no other way to simplify that. So that is actually your final answer. You can leave it written like that with that plus or minus sign right there. That represents the two solutions. You don't have to list them out separately. You're just going to put that in the curly brackets, and see, we all make funky curly brackets, myself included. Just give it your best go. And that's your solution on that. So you are going to start to see more problems like this on the medium, where the answer includes a radical. Just make sure you always simplify that radical if you can. The spicy is extra complicated because you're going to start to run into some b values that are odd, and you end up with fractions, so you're completing the square with fractions and radicals that don't simplify. So just keep that in mind in terms of how difficult you want your work on this to be. You are now ready to complete one assignment from the second row of the choice board. I'd recommend getting at least one of those completed before you move on to C.